Hello everyone, I'm Song Yatong, an algorithm engineer from Meituan. Firstly, I would like to thank all co-authors for their efforts, and also thank all reviewers for their insightful suggestions to this work. Then, I will present our work, a semantic segmentation-based POI coordinates generating framework for on-demand food delivery service from the 5 aspects: the background and the challenges, our contributions, methodology, evaluation and analysis, and the conclusion. First, let's take a look at the background and the challenges. As we know, recent years on-demand food delivery service has become very popular in China. The daily order volume of takeout has exceeded 40 million on Meituan app, which is the largest on-demand food delivery platform in China. As shown in the left figure, users can explore the online restaurant marketplace, choose restaurants, and order their favorite foods. Then the delivery system will dispatch waybills to couriers, who will deliver the foods to the corresponding users. The efficient delivery system relies on high intelligence algorithms and accurate geographic data, such as the POI coordinates. These coordinates are used as designations of navigation routes for couriers and play important roles in downstream businesses such as the delivery price, ETA, delivery scope, and order allocation. However, the existing POI data has some vital drawbacks. The most severe problem is coordinate deviation. The reasons could vary from GPS drift to human error and so on. Due to this problem, couriers often complain about being directed to the wrong destinations as shown in the left figure. The user address is Huaguoyuan Building 3, Community T, but the coordinate is drift to Community 1, which is more than 1 kilometers from the real user location. Meanwhile, lacking coordinates of fine-grained address text is also a problem that affects couriers' experience greatly, as shown in the right figure. The user address is Xiamen Software Park Building 10, but the POI coordinate is located at the center of the software park, which is about 200 meters away from the real user location of Building 10. These problems often perplex couriers seriously and cause the many complaints to the platform. But why fine-grained coordinates are so important to food delivery service? Let's see the contrast between the ride-hailing service and the food delivery service. Ride-hailing platforms and food delivery platforms have some similarities, such as mining POI based on the behavior data of couriers or drivers, and the POIs are displayed for couriers or drivers' navigation or help users place orders. They also have several differences. For instance, the drivers are usually pick up people on the roadside. The ride-hailing service mainly pay attention to the entrances, exits, intersections, and main roads. The green pinpoint in the left figure is where the driver picks up people. This point is called the boarding point. As for food delivery service, users usually provide more fine-grained addresses to the platform, expecting to receive their food timely without extra work. This phenomenon causes the route in the instant delivery scenario to be significantly different from the ride-hailing platform. And couriers always ride electric bicycles on low-grade roads within the community where cars cannot get in. Therefore, precise coordinates of fine-grained addresses are significantly important for couriers to find their destinations. The yellow point in the red figure is where couriers deliver food to people. These points are called delivery points. After we understand the problems we have to solve, I'm going to talk about the contributions of our work. The first contribution is potential impact on other services. We built a geographic hierarchical structure to model the physical world by parsing the address texts, which can also be used as a user portrait for any service correlated to users. The second contribution is to bridge geospatial data with deep learning computer vision techniques in our research, revealing the great potential of applying these popular techniques directly to geospatial data. The third contribution is to tackle coordinate deviation and lacking problems and further improve the downstream businesses such as scheduling, pricing, and so on, thus improve delivery efficiency and user experiences and courier experiences. Next, I'm going to concentrate on our methodology. Our delivery point inference framework is mainly divided into four parts. The first part is input data collecting. We use four categories of Waybill data. They are user addresses, user location points, courier check-in points, and POIs from database. Secondly, we built a geospatial hierarchical structure by AOI mapping and address parsing. This step is aimed to group waybills into address groups, which have the same AOI name and POI name. In the third step, we generate the data density image for each address group. These images are used as trained data for a UNet model in the fourth step and infer delivery points. For the input data, each waybill has a user location coordinate, a courier check-in point, and a raw POI coordinate in our database. This is an example of 300 waybill data of a building from an industrial park. This data will be used as the input data of our framework. The first module of our framework is to build a geospatial hierarchical structure. We launched a voting mechanism and a text similarity algorithm to find which AOI a waybill belongs to, and then use an address parsing model to find the POI name of each waybill. Examples of geospatial hierarchical structure is shown in the table at the bottom. R refers to the address groups. Waybills of the same address group share the same AOI name and POI name. After we get the address groups, the following work is to generate data density image for each address group and predict the coordinate of the delivery point. We use neighboring address groups data as negative signals and current address group data as positive signals to generate this data density image. The blue points represent negative signals, and the red points represent positive signals. Couriers check-in points and user location points are processed into data density images, respectively. Then we feed the data density images to a UNet model to predict the real coordinates of POIs. Follow up, let's take a look into evaluation and analysis. In experiments, we compute the deviation distance between the predicted delivery points and the courier's check-in points to assess the precision and the practicability from the perspective of couriers. And 3 baselines were used to certificate the effectiveness of our framework. The first baseline is using raw POIs from geospatial database. Another baseline is GeoHash density center. The third baseline is isolation forest clustering. To make a fair evaluation, we built 2 evaluation datasets with data originated from 2 cities, namely Beijing and Shanghai, to reduce the bias from different regions. The results are shown in the table on the right. The results clearly shows that the delivery points predicted by our framework are much closer to the check-in points, and the same trend is found in both Beijing and Shanghai datasets, revealing the robustness of our method. We also launched the visualization method to check concrete cases. As shown in the figure on the top left corner, the blue points are the delivery points generated by our framework, and the red points indicate the true values of those POIs. It's easy to find that the delivery points are close to the true values of those POIs. What's more, we can also discover that the performance of the model is stable and is insensitive to area size and the POI number of an AOI. The figure at the bottom left corner is two cases of delivery points collaborating deviated POIs in a geospatial database. These two cases show the delivery point is consistent with the actual address described. We also make a large-scope visualization of delivery points in the figure on the right, which shows the general effectiveness of our framework. To summarize, we proposed a framework to inference POI coordinates from the courier and user behavioral data, and the experimental results and the case studies on two large-scale real-world datasets suggest that our model have better POI inference performances. That concludes our presentation. Thank you for your listening.